The inevitable end. The universe had a beginning, but will it also have an end? Just like everything else, the universe we inhabit will one day reach its inevitable conclusion. Will it freeze in an endless void? Will it collapse in on itself? Or will it suddenly be torn apart in an unexpected catastrophe? Scientists are searching for answers to these profound questions. However, to truly understand the fate of the universe, we must first grasp its nature and how it operates. The birth and expansion of the universe. The universe was born about 13.8 billion years ago with the Big Bang. At that moment, everything space, time, and matter was compressed into a point smaller than a pinhead. Then, in a fraction of a second, the universe expanded at an unimaginable rate. Today, all the galaxies, stars, and planets we know are a result of this vast expansion. But one crucial question remains. Will this expansion continue forever? Or will it eventually stop? The answer will ultimately determine how the universe will end. To measure the expansion rate of the universe, astronomers observe distant galaxies and analyze changes in the wavelength of their light. In 1929, Edwin Hubble made a groundbreaking discovery. Galaxies were moving away from us, and the farther they were, the faster they receded. This was the first direct evidence that the universe was expanding. Then in 1998, observations of distant supernovae revealed something even more shocking. Not only is the universe expanding, but it is doing so at an accelerating rate. The mysterious force driving this acceleration is what scientists call dark energy. Dark energy is believed to make up roughly 70% of the universe's total energy. However, we know very little about its true nature. If dark energy behaves differently over time, or if it becomes stronger, the universe's fate may be entirely different from what we currently predict. The Big Freeze, a universe without heat. If the expansion of the universe never stops and continues to accelerate, a time will come when galaxies will be so far apart that even light will not be able to travel between them. The universe will become a dark, empty void where cosmic structures drift further apart, beyond each other's gravitational reach. The stars we see in the night sky will slowly fade away as they exhaust their nuclear fuel, leaving behind lifeless remnants such as white dwarfs, neutron stars, and black holes. In this scenario, black holes will become the last dominant structures in the universe. Over immense periods, they will slowly evaporate through Hawking radiation, releasing their energy back into the void. With no new stars forming and no more sources of energy, the universe will descend into a state of extreme entropy. At this stage, even the fundamental particles that make up atoms may decay, leaving behind only a vast, cold emptiness. This process is known as heat death, where entropy reaches its maximum and the universe becomes a stagnant, lifeless abyss. No new structures will form, and no energy will be available to sustain any form of activity. In a sense, the universe will exist in name only an infinite expanse of nothingness, where even time itself may lose meaning. The Big Crunch, a universe collapsing inward. What if, instead of expanding forever, the universe's expansion slows down and reverses? This scenario leads to what scientists call the Big Crunch, where gravity reclaims its dominance, pulling galaxies, stars, and planets back together in a cosmic implosion. In this scenario, the expansion of the universe will eventually decelerate as the gravitational attraction between galaxies overcomes the repulsive force of dark energy. As a result, galaxies will start moving closer to each other, and the entire universe will begin to shrink. As space itself contracts, temperatures will rise, and matter will become increasingly compressed. Stars will reignite, colliding with one another, while black holes will merge into larger and larger singularities. Over time, this process will accelerate until all matter and energy in the universe are crushed into a single, infinitely dense point similar to how the universe began. If this happens, time itself might come to an end, and everything we know will cease to exist. Some physicists speculate that this could lead to a new Big Bang, starting the cycle all over again. If this theory is correct, the universe could be trapped in an eternal loop of birth, destruction, and rebirth, repeating the same cosmic dance indefinitely. The Big Rip, a universe torn apart. Could dark energy be even more powerful than we think? If dark energy grows stronger over time, it may not only accelerate the expansion of the universe, but also tear apart everything in existence. This scenario is known as the Big Rip. In this catastrophic outcome, dark energy will continue to increase its influence, stretching space-time itself at an ever-growing rate. At first, galaxies will drift away from each other faster than the speed of light, making the observable universe appear emptier over time. Then, the expansion will begin to affect smaller-scale structures, breaking apart galaxy clusters, then individual galaxies, and eventually even solar systems. As the expansion intensifies, stars will be ripped from their orbits, and planets will be torn apart. The gravitational bonds that hold everything together will fail one by one. In the final moments of this scenario, even the fundamental forces that bind atoms together will succumb to the relentless pull of dark energy. Molecules, atoms, and subatomic particles themselves will be stretched beyond their limits and annihilated. Space-time itself may fracture, marking the complete disintegration of reality. If the Big Rip is our universe's ultimate fate, it could unfold much sooner than other predicted scenarios, possibly in just a few billion years rather than trillions. However, this outcome depends heavily on how dark energy evolves over time, a mystery that remains unsolved. Other alternative scenarios. There are other lesser-known but equally fascinating theories about how the universe might end. One such theory suggests that our universe is part of a multiverse, a vast system of interconnected universes. If this is the case, our universe could collide with another one, resulting in its destruction. Another possibility is related to quantum mechanics. The universe might not be in a perfectly stable state. If so, a phenomenon known as vacuum decay could occur. A small quantum fluctuation could trigger a shift to a lower energy state, expanding at the speed of light and wiping out the entire universe in an instant. Some researchers even speculate that time itself might come to an end. If time stops, the universe as we know it will simply cease to exist. However, this idea remains highly theoretical and lacks concrete evidence. Do we really know? Today, we have several theories, but no definitive answer. To truly understand how the universe will end, we need to unravel the mysteries of dark energy, quantum physics, and the fabric of space-time. However, one thing is certain. The universe's fate is a profound question that continues to captivate both scientists and the general public. What do you think will happen to the universe? Share your thoughts in the comments. Subscribe for more videos on space and science.